This video presents the basics of Bernoulli trials. Bernoulli trials are a random phenomenon with these characteristics. The trials are independent of one another. Each trial has only two possible outcomes. Now, oftentimes people refer to these outcomes as success and failure, but you should not take these terms literally. Success could be any outcome that we're interested in, and failure could be the other outcome. The probability of success on any trial, which we abbreviate with a lowercase letter p, is the same for all trials. So those are the three characteristics of Bernoulli trials. Examples, repeated flips of a coin. If you define a success as getting heads, then of course a failure would be defined as getting tails. The probability of getting a heads would be little p, and that would be 0.5 on all trials. If you roll two dice, you could define success as getting a 7, and failure is getting anything else. Then little p, the probability of success, is equal to the probability of getting a 7, which is 1/6 on all trials. If you repeatedly draw one card from a deck of 52 with replacement, then you could define success as, say, drawing a face card, and failure as drawing anything else. The probability of success is the probability of drawing a face card, which would be 12 out of 52, or 3/13 on all trials. Now, Bernoulli trials show up in two important settings that we're going to look at. The binomial setting. In the binomial setting, the number of trials, which we abbreviate with the letter n, is fixed. The random variable of interest, which we call x, is the number of successes in the n trials. The binomial random variable x has a binomial distribution with parameters n and p. If you know n and p, then you can completely specify the particular binomial distribution that you're talking about. And we abbreviate that statement as x has the binomial distribution with parameters n and p. Now, x can take any integer value from 0 up to n inclusive, but it can only take integer values, cannot take any value in between. This is a number of successes, so it could be 0, 1, 2, 3, 4, up to and including n, but those are the only values that x could take. So it's a discrete random variable. The other place where you're going to see Bernoulli trials is in the geometric setting. In the geometric setting, we have an indefinite number of trials. We just keep trying until that first success occurs. The random variable of interest in this case is the number of trials necessary to achieve that first success. This geometric random variable has a geometric distribution with one parameter, p, the probability of success on any trial, and this variable x, it can take any integer value greater than or equal to 1. You have to try at least once in order to get a success, so x can't be less than 1. And x is going to be any whole number above from 1 up to potentially infinity. These trials could continue indefinitely without a success, and so x could potentially take very, very large values. We're going to look in our next video, we'll look at the binomial distribution, and farther on down the line we'll look at geometric distributions in more detail.